So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, energy storage systems will be ubiquitous. Everybody's going to eventually have them. Utilities want to install these energy storage systems to balance their intermittent demand of electricity and the intermittent generation of electricity. Homeowners are going to be putting these systems in for energy time shifting, for storing their daytime solar power and using it at night, and for backup power. And commercial customers are also putting these systems in because they want to reduce something called a demand charge on their electric bill, which can be a huge charge. And they want to time shift when they're using their electricity, store their own solar power, and also a lot of commercial customers are looking at the advantages of having a reliable source of backup power. Now, like solar, energy storage systems or battery backup systems help us get cheaper and cleaner electricity. There are big rebates and tax credits for these systems currently. Now, we've done entire shows on residential energy storage backup systems, and there's something in California called the SGIP program. That's the Self-Generation Incentive Program that has some pretty big rebates that make a lot of sense for homeowners who are looking to reduce their electricity bills and get backup power, because we need backup power now. Our grids become very unreliable. Now, commercial customers are also moving towards these systems. Now, the utility market is already booming. The utility market for energy storage systems is booming for one simple reason. These energy storage systems that your utilities are putting in are basically not paid by the utilities, but they're paid by ratepayers. And they're actually needed. So it's relatively easy for utilities to justify new energy storage projects, and they can just get millions and millions of dollars approved by the Public Utilities Commission to put these systems in, and that will help us use more renewable power on the grid. Unfortunately, when utilities put these systems in, it doesn't help reduce our energy costs. In fact, I'm convinced that when utilities put these energy storage systems in, it's actually going to increase our electricity costs. The way we are able to reduce our electricity costs, whether it's a business or homeowner, is to put systems in behind the meter. Invest in these systems on your own, and you get the benefits directly. All right. The commercial market for energy storage systems is relatively untouched, and that's the focus of our show today. Businesses are putting in these energy storage systems with solar and without solar. They save a lot of money. Obviously, if you have solar on the roof, you're going to save even more money than if you have just a regular energy storage system. Now, there's another reason why these energy storage systems are starting to take off. There's more buzz about them because of the incentives that reduce those upfront costs. So specifically, we have the Self-Generation Incentive Program. We have the Federal Investment Tax Credit. We have accelerated depreciation. When you kind of add all these things up, it could pay for 2/3 to maybe even more of the cost of the systems. And that brings paybacks down into a pretty good range. So, all right, let's take a look at how businesses are saving money with these energy storage systems. Now, the most obvious one, it doesn't take a genius to figure this out, is a business has backup power. Now, maybe not the full amount of backup power that you ordinarily have to run your business, but you can easily put in a system that's set up to keep your computers running, to keep your lights on, to keep your transactions going. So if you're a retail business and you want people to come into your store or come into your gas station and buy gasoline and pump gas, well, you really need power. And when you're out of power, the lights are off. People are just going to drive by in their cars going to another station that has backup power. So the backup power really can keep the business going when there's a blackout. And there's some businesses that are using production equipment or manufacturing equipment, and you really don't want those systems to shut down. All right, so the backup power is one. It's kind of obvious. Next one is called demand charge reduction, and we'll talk about that more in a minute. The third is peak electricity usage shifting. And the fourth is increased self-consumption of this own solar power that you may be generating on your own roof. All right. Now let's talk about backup power. I mean, it's been surprising and disappointing to me over the past few years as I've observed our local grid here in California becoming less and less reliable. And I don't really know exactly the reason for that. I think it's just basically because The utilities are saving money by not doing the maintenance they need, not doing the upgrades. And they're also not keeping up with the changing habits of consumers, businesses, and homeowners, putting in more equipment, more air conditioning, more electric vehicles, more appliances. And, literally what's happening is transformers are just blowing all over the place. I mean, you could just look at the map online, look at power outages, and you're going to see that there's power outages almost all the time. And we're not talking about storms. Talk about storms. We've had several hurricanes. We've got disastrous fires. There's earthquakes. I mean, these things happen. And when those things happen, power's out for a long time. So the grid's less reliable. That's, as I mentioned, that's inconvenient for some businesses and can really, you got to send people home. But when you have a retail business or a manufacturing business, it can really hit your bottom line. So that's where businesses are looking for a reliable source of backup power. And we're kind of fortunate because these tax credits and incentives cover that because you've also got some additional benefits to the grid. We'll talk about that more later. Okay. The one that a lot of businesses just kind of immediately look at because you can see it screaming at you right on your electric bill is something called a demand charge reduction. So, you're going to say, what's a demand charge? Okay. When you look at a commercial electric bill, you also have three major components on that electric bill. You have your fixed daily charges. So for business, these fixed daily charges may be 50 cents or, $50 or $100 a day. Now, on your residential electric bill, you also have a small daily charge. That's usually like 50 cents. It's really low, so you don't even notice it. But, for businesses, these numbers can add up pretty quickly. The bigger your electric bill and the bigger your facility is. The second charge is one that we're all pretty accustomed to. We get charged based on the amount of energy we use. That's called the energy charge. It's measured in the number of kilowatt hours you use every month. So for a business, it might be 15 cents per kilowatt hour. So, if you're buying 100,000 kilowatt hours in a month, you're looking at a bill that's going to be $15,000 just for the electricity charge, the energy charge. And on a home bill, this is what we look at all the time. It's like, what's my average electric rate? It's 20, 30, 40 cents a kilowatt hour. And here in California, I would say that the peak rates are closer to 40 cents a kilowatt hour. Average rates are more like 25 or 30 cents a kilowatt hour. And businesses get a break on electricity because they buy quote and volume. Okay. The third charge is the important one that storage systems help resolve. It's called a demand charge. And that's measured by the peak number of kilowatts you use every month. It's not an energy charge, it's a power charge. So these demand charges might be $15 per peak kilowatt every month. I'll run a quick example. So let's say you have a bill of 200,000 kilowatt hours a month and a peak demand of 1,000 kilowatts. Your bill would be about, I'm going to add this all up, you'd have about $1,500 of fixed charges, you'd have $30,000 of energy charges, 200,000 times 15 cents, and then you'd have $15,000 of demand charges. So your total bill is $46,500 a month. But if you had a battery system, you could discharge that battery when you need to so that you reduce that peak demand charge. That's how we're saving there. So let's say you reduce your peak demand from 1,000 kilowatts to 800 kilowatts. That doesn't sound like much. It's 200 kilowatts, but 200 times $1,500, you save $3,000 a month. That's number two, the demand charge reduction. Number three is the peak electricity use shifting. So a lot of customers are on a time of use rate. It's mandatory. Utilities charge more money for electricity during peak times than they do, an off-peak time. So summer weekday afternoons, electricity is expensive. So if you could charge your battery in the morning or the evening when electricity is inexpensive, and then during the day, when you're looking at these high bills, you discharge the battery, you might be able to knock 5 or 10 cents a kilowatt hour off of the energy charges. So that's called peak electricity usage shifting. Now, the fourth one is similar. It's called increased self-consumption of solar power. Let's say you have solar on your roof. You're producing most of your solar between 10 a.m. and 2 p.m. middle of the day, all week. Now, electricity rates, once again, are usually highest for commercial customers in the afternoon. So on ordinary solar systems where you're running the meter backwards with net metering in the middle of the day, you might be getting credit at 10 or 15 cents a kilowatt hour, but you're still getting hit with those high peak charges from 1 p.m. to 5 p.m. So if you were to store your solar instead of running the meter backwards, you're able to use that solar power when it's more valuable to you. And that's basically how that works. Okay, so what does all this add up to? We're talking about kind of four factors: backup power, demand charge reduction, peak electricity usage shifting, and increased self-consumption of solar. What does this add up to? Well, I can't really come right out and say it because it depends on your electric rates. It depends on your business's use of energy. Kind of, are you using a lot of power during the day, in the evening? Is it production equipment? Do you have a lot of spikes or just a few spikes that are predictable? And it depends on the size of the system you install. I can tell you that the companies that are putting in these energy storage systems with solar typically are seeing paybacks in the 3 to 8 year range. And usually with financing, they're getting immediate positive cash flow. So these are good investments. And so we're going to go into the details later. But, we're looking at paybacks in the 3 to 8 year range. And, down, if you can get it down below 5 years, a lot of companies are very interested, especially companies that can get the added benefit of backup power. And, I'm also comfortable with these systems now because these aren't kind of cobbled together systems from no-name companies. These are systems that are made by big manufacturers like LG, like Delta, like SMA. So we're talking about something that's reliable electrical equipment, not something that's just kind of bleeding or cutting edge. All right, here's what goes into an energy storage system. We've got big batteries, and those batteries store DC energy. Now, we used to rely on lead-acid batteries, but now we're using various types of lithium-ion batteries. The advantage of these lithium-ion batteries, there's a number of different chemistries, is these batteries are lighter, they're smaller, and they last much longer. So we don't need these like fancy heavy-duty enclosures anymore. It's something that almost can be packaged very, very nicely in an enclosure. It's something that mounts on the wall or something that goes in a standard cabinet. And these cabinets also have battery management system, so everything's integrated to manage the charging and the discharging. Big improvement over the kind of systems I used to install 15, 20 years ago. All right. The next part is that you've got energy. And where does the energy come from? Most people are generating the energy, the electricity from solar on the roof, but you can also charge these batteries up from power from the grid. All right. Now, solar power is DC power, and batteries have to be charged with DC power. So when you're charging from solar, it's kind of easy. It just goes right into the batteries. But if you're charging from grid power, you need to have a converter to go from the AC power from the grid into the DC power that charges the batteries. And the inverters in these energy storage systems all have that kind of conversion built in. All right, I mentioned the inverter. The next big component, this is probably the single most expensive thing, is the inverter that converts the DC power from the battery to usable AC power. So if there's a blackout, you can't run everything on DC power, because those are just, it's just not going to run your appliances, your lights, your equipment. You have to invert it into usable AC power. It's a standard piece of equipment. Anybody that's got a solar system on their business or roof, you've got inverters, and that's been, these things work flawlessly for years and years and years. Okay, another component, control electronics. These control electronics manage the state of charge of the battery, and they kind of make the decisions based on your rules and based on the electric rates of when to discharge the batteries, when to charge the batteries, when to use grid power, solar power, et cetera, et cetera. And there's software that makes all of this work. And the software has to be programmed, and it's pretty standard, so that it's optimized for your commercial electric rate. A lot of companies are on different rates, and different parts of the country have different rates. And businesses have different energy use profiles. And you also have to make sure that you're kind of anticipating what the status of the battery is going to be and the solar availability. And these systems also have communications capabilities so that they can communicate to whoever's managing the system, to your company, and then also to your installer who's providing operations and maintenance support. Okay, so let's talk about a use case. Here's how these systems operate. So for example, let's say your employees come into work at 8 a.m. in the morning. Now, a lot of companies have electric vehicles. The employees are plugging their EVs in all at once. They get to the office at 8 o'clock. You might have 50 people plugging in their EVs. But each one of these EVs draws a lot of power. That's going to dramatically increase your demand charge. So I'm just kind of running through some quick numbers here. Each car on a standard level 2 charger may draw 4,000 watts. So if you have 25 employees who all come in between 8 a.m. and 9 a.m., suddenly the peak demand, when you used to not have a peak demand because those people drove gas cars, 25 people are plugging in their cars. Now there's 100 kilowatts more of demand charge. 100 kilowatts times $15 a month, $15 a kilowatt, that's an extra $1,500 that you may be paying in addition to the energy charge. This is just a demand charge. People are still drawing energy because you're providing the service. Now, it's a great service. It's a great benefit for employees, but it's one of these surprises that companies putting in chargers, boom, suddenly your demand charge goes through the roof. So you can use a battery storage system to kick in, say, between 8 a.m. and 10 a.m. when everybody plugs in at once in the morning, And that's also going to help reduce those charges, because if you have solar on the roof, your solar is going to start cranking out 10 o'clock, 11 o'clock. So the battery is going to pick up that gap and reduce that demand charge. So there's one use case. All right. Another use case, it's very typical. It's a really hot day. All of the air conditioning systems in your building kick on at once. Once again, these are big compressors. They may draw 100 amps. That's going to be 20,000 watts, and that's also going to raise your peak demand pretty significantly. So the battery storage system would be watching this peak, and they suddenly see, oh, it's hot. There's this spike that might go on for half an hour, and the battery could discharge at that time, once again, to reduce that peak demand. Okay, another scenario. I've seen this thing happen often in my office and also at home on a really hot day, hot afternoon. The grid gets overloaded. All the companies are kind of running their air conditioning full blast, but they're still running their businesses, and people are still charging up their cars. We have plenty of power. The independent system operator in California is making sure that there's enough power kind of coming from power plants, coming from solar, coming from hydroelectric dams, even coming from storage systems that utilities have. And they're sending this out over the wires. But when it gets to the local grid, the local distribution system can handle all of this sudden activity on a hot afternoon. What happens? A transformer blows out and you get a local blackout. It could be a transformer on top of a pole in a small office park. It could be one of these bigger transformers in a business park. And then everybody's in the dark. Now, if you had a battery storage system, your business would have an automatic backup system that would kick in to power your critical loads. So you may have a momentary power outage, the lights flicker. Everybody else in your business park or all your competitors are out of power, but your lights could be on, your computers are on, your refrigeration system, say you had a convenience store and you wanted to keep your items in your freezers cold, gas pumps, would you still be able to pump gas? You'd still be able to use your cash registers and process credit card transactions. So basically, you're not going to shut down your business. You may have a process business where you've got some continuous processes, some equipment that has to stay on, has to stay hot. You don't want that to cool down. I mean, I've gotten some friends that are running solar power panel manufacturing facilities. When there's a power outage, they're kind of, everything that's on that production line is going to have to be thrown out. If they only didn't have any of that interruption, they could keep that production going. So this backup power is really useful on a hot day when the grid fails. Okay. So you can see that there's benefits there. What does this mean in terms of dollars and cents? Well, let's talk about what a sample system would be. We're just looking at kind of an average size commercial system. I'm going to start throwing out some specs here. Much bigger than what you'd have on a residential system. Average size commercial system, 125 kilowatt inverter. That's going to be in a cabinet. It could be mounted on the wall. It's usually installed outdoors. You'll may have 330 kilowatt hours of batteries. This would be in kind of 3 stacks of batteries and enclosures. And there'll be control hardware in there and software that runs the whole thing. So how would this system work? What are the financial benefits of this system in the scenarios that I talked about? All right. It really depends on the circumstances of your business, but here's a typical one. You may see annual demand charge savings of $14,000. It really depends on your business, but let's say it's $14,000. Now, let's put aside for now the blackout savings, the resilience savings, because that could be pretty considerable. So if we're looking at a system like that, the equipment is going to be something in the neighborhood of $286,000 plus some annual maintenance of about $1,200. But the good news is there's a $67,000 rebate from the state, $71,000 investment tax credit, and in the first year, you're going to see depreciation benefits of $17,000. So that means your first year net costs are going to come down from $286,000 down to only $130,000. That means you have a simple payback. Still, it's kind of, it's not super short. It's about 8 years if you don't consider the blackout benefits. But if you're running a retail business and you lose $10,000 a day in retail business, I can pretty much guarantee you that if in most places in California, you're going to see power failures that are happening more often than once a year, and you're going to save quite a bit of money because you're going to have that backup power. That's worth $10,000 a day. Obviously, it depends on your business. In some cases, it could be a lot more. Now you're bringing your payback down to 4 or 5 years. All right. Now, this situation gets a lot better if you finance the system with something called PACE, or Property Assessed Clean Energy. Now, these are loans that you can get. It's going to be paid through your property taxes. There's no upfront purchase costs, but you also get some tremendous tax benefits up front. My jaw dropped when I kind of looked at these benefits in sum. You end up with $126,000 positive cash flow in the first 5 years. So for some businesses that are able to take advantage of these PACE savings, and especially businesses that really need a steady, reliable source of energy, heck, you're looking at $100,000 or more of positive cash flow, plus all the other benefits you have, plus even more if you're going to couple it with solar. So my advice, it's pretty simple. There's three criteria, three characteristics of a business that are going to make this very attractive. First, does your business depend on a reliable source of electricity? Are you going to be out of luck if the power goes out for an hour or a day? Second, do you pay high peak demand charges and high energy charges? Most businesses in California do. And third, does your state or utility provide incentives for energy storage systems? So if so, it's definitely worth the time to meet with a knowledgeable local energy storage system provider. Okay, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can always go to our website at cinnamonsolar.com and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.